Hello, in this video, we are going to do some more rate law practice. So first, here are some important reminders about why rate laws are important and the information we can get from them. So go ahead and pause the video and refresh on all of the aspects of rate laws that we should know about. Okay, so let's go ahead and apply our knowledge of rate laws to this question. Let's consider this reaction. 2NO plus 2H2 makes N2 plus 2H2O. The rate law for this reaction is first order in H2 and second order in NO, and has a rate constant of 6.0 times 10 to the minus 4 molar to the minus 2 inverse seconds. What is the rate law and the rate when NO concentration is 0.050 molar and H2 concentration is 0.010 molar? So pause the video and try it for yourself. Okay, and so let's go ahead and talk about it. So we need the rate law. We're given information about the reaction. It is first order in H2 and second order in NO. The orders are the exponents for the reactants in the rate law. So that means that our rate law is as depicted, R equals K times H2 times NO squared. What is the rate then when the concentrations of NO and H2 are given? Well, this is going to be simple substitution. So we plug in our values of rate constant, concentration, and apply the correct exponents. Our answer is the rate will be 1.5 times 10 to the minus 8 molar per second. Another question regarding the same reaction. If an experiment is begun with both NO and H2, the rate is 2.0 times 10 to the minus 6 molar per second, and we know that H2 is equal to 0.020 molar, then what must the concentration of NO be? Again, go ahead and pause the video and try it yourself. Okay, so let's go ahead and talk about it. Again, we want to dissect what's been given to us and how it relates to reaction rates, rate laws, etc. So again, we know the rate law from the previous work. And now we check for what we want. We desire the concentration of NO. So much like any other equation, we can solve for what we desire. So we'll move our NO to the other side, or all of our other things to the other side. Since it's squared, we have to take the square root, and we substitute carefully what was given to us. That gives us a concentration of NO must be 0.41 molar. It must be that because all reactions abide by their rate law. So if we know the rate, we know the rate constant, and we know the concentration of one of them, we can solve for the concentration of the other. Now, how about this question? We want to determine some information about a reaction, determine the orders of reactant W and reactant M, the rate law expression, and the overall order in the reaction. 3W gas plus 2M gas makes 4P gas. There are 2 bullet points of information. Let's look at the first one. When M is constant, if W decreases to 60% its initial concentration, the reaction rate decreases to 36% its initial rate. How can this help us figure out what the rate law expression is going to be? Well, what do we know about how the rate is affected by changes in concentration? Let's take a look at what's happening here. So it says that if W decreases to 60%, then the reaction rate decreases to 0.36%. So first of all, we know that changing the concentration of W changes the rate. So therefore, we can eliminate that this is going to be a 0 order with respect to W. So let's go ahead and write down what we know. W final is 0.6 times W initial. So that's what it means when it's now 60%. And same thing for the rate, we can dissect it. The final rate is 0.36 times the initial rate. How can we determine the order? Let's think of ratios. So the ratio of the final concentration to the initial concentration is 0.6 from the given first part of the statement. And the ratio of the rates is 0.36. So now we think, how does the ratio of the concentration relate to the ratio of the rates? Well, if we take a moment to think about it, or we set up the ratio analysis, 0.36 is 0.60 squared. So therefore, when I multiply my concentration by a factor, my rate is multiplied by that factor squared. What does that suggest as far as the order for W? Okay. How about the second part? When W is held constant, the plot of reaction rate versus concentration of M is linear with a positive slope. So take a moment to think about what that means, and maybe drawing a graph would help. So in this case, here we have the graph as the concentration is plotted on the x-axis, the rate is plotted on the y-axis. It is a positive slope telling us it linearly changes when my concentration goes up, for example, then the rate will go up by a similar factor. What does that suggest about the order of M? So put the two pieces of information together. What do you get as our rate law? Our rate law is going to be R equals K times W squared times M. It is second order in reactant W, and it is first order in reactant M. Therefore, the total order, or the overall order, is going to be 2 plus 1 equals 3. We add the exponents. Alrighty, I hope that helped.